So guys, welcome back to my channel, and this one must be part 5. Yeah, it's part 5. We have just of the ATS, preparation of the ATS. Already I've done the wiring, and it is done, complete, it is done. Yeah, today being on a Sunday, I'm just here with my colleague. He's working on a small VFD here. It's Mr. Ashish from Bangladesh. And we are working on, he's also working on this Himmel VFD, small one. This 1.5 kilowatt. This Himmel we have dealt with it several times. So yeah, but just in case of anything, I can also talk about it. But already now I've finished this ATS wiring. I'm done complete 100%. Apart from, actually it's not 100% because there's door wiring which is waiting here, but I've already done all the wiring here, and it's remaining to do the final termination on the door. Then finally we shall do our tests, see whether our ATS is working or not. So basically there are 2 or 3 things, few things we shall discuss here in order to clarify on what is going on. Yeah, we have to have a good picture of what is happening here. So I'll just start with the simplest part. Like in this case, you can see this one is we have 3 CTs. This CT is for the multifunction meter there. You can see it there at the door. So this CT, we have the CT for the red cable, yellow cable, and the blue cable. Okay, we shall not go too much discussion on the CT. This one we have done on several occasions. So I won't do a repetition of the discussion. We can as well check with my other videos in case you want to learn much about cities. Yeah, so but what I have done, you see one side is grounded, which I have looked in all these cities is grounded, and at the same time we take it as a common outside. So we are taking outside one, which we shall loop on the multifunction meter. So the city will take its red cable, yellow cable, and blue cable. But this black one is a common. You can take two cables, but in this case we have decided to take 1 cable because it's just a common. It is connected. When you loop here the ground, you have connected all of them. They're in the same potential. So when you take 1 cable, it's just as well. It's okay. So that's for the city, and this one is our MCCB 300 amps. This is the outgoing RYB, and the neutral here is a common outgoing for this is our main supply from the utility company. In our case, this is DIWA, and this was from the generator. So they have a common outgoing. You see it is joined. They have an interlock, so both of them cannot be switched on at the same time. They cannot come on at the same time. There's an interlock. We have both a mechanical interlock and electrical interlock. The mechanical interlock, already there's a previous video. If you're following a series of my videos, there's a video that I have discussed and I've shown how to go about the mechanical interlock. Today we shall discuss the electrical part of the interlock. So it's a common outgoing through those bus. Yeah, and we have our outgoing MCCB. Our MCB here is 400. It's 400, but we shall do our setting because it is 300. It's 300. We shall do our setting there. As you can see, even our CT is here 300 is to 5 amps. Yeah. So so this is the top side. The top side, we have this 4. Actually, it's a 4-pole MCCB. This one is also 4-pole, because we cannot have a common neutral from both generator and the utility company. So this one is from the utility company, this is from the generator. So I'm taking this my first MCCB as the utility, and this one is the generator. So that's the incoming, and our outgoing is from the bottom here. You can see this is our outgoing. So I have indicated here the mains incomer, the generator incomer. Okay, and that is clear. Then from here, from our incoming mains, I have put here N1, neutral 1. This is neutral 1. Neutral 1. This one is D1. D1 yellow. And D1 also here, blue. And red. Red, D1. All of them, they D1. And this one, in this case, my generator I have denoted by, generator side I have denoted by E1. This one is like emergency. Okay, I don't have the G. I could have used the generator. I don't have that parallel. I don't have that number or letter. I don't have the letter G. So what I've just done, I've used the emergency E1. And this case, the neutral is N2. My outgoing is a common neutral. So this one is a common neutral. This is common phases. So my outgoing, I have denoted all of them by 0. You see, 0 0 0 0 for outgoing, 0 0. After this fuse, after this fuse, we are going to the lamp, to the outgoing lamp. After this fuse, we are going to these lamps. Here I've denoted by V1, V1, V2, V3. This is the common outgoing, and also for the multifunction meter, we shall use the common outgoing. So either when we have the D1, or either when we have the generator, still this one multifunction will indicate. These lamps on the other hand, you see, N2, these are from the generator side, and this one N1, this one is for the utility side. So through this fuse, you can see our first fuses here. Our first fuse here, D1, and N1. Then the outgoing is just D, which will go to the lamp. The cables are here, out. Then we have this one, E1, and we have E. This is outgoing. So this D is also supplying our, this one, PMR1, which is phase monitor and relay 1. From this fuse, you come round, you energize, you supply this one. So this one will monitor. If in case maybe one fuse is gone, it will indicate it's not okay. In case maybe there is a phase sequence is altered, this one will not switch on. You can see my common here is 11, my normally open is 14, and my normally close is 12. So this one is an open. So in case everything is suitable here, the voltage is okay. In this case 400 volts, and the sequence is also okay, and maybe there is no voltage drop or over voltage. So this one will switch on and everything will start. So as far as the lamps, these fuses they are concerned, this one will go to the lamps outside, it will supply here. And also this DI incoming, I've also looked here to this fuse. This fuse, it is given outgoing to 20 here, this to 24, this for battery charging, this breaker. I've used a 20 amps, but you can use a 10, even 6 amps, doesn't matter, for charging the battery. Yeah. So these are also outgoing, they are going to the door. This one is also for the generator side. Going to there, so it's monitoring rail 2, and also going to the lamps outside. Yeah. So let's focus on our drawing here. This is a circuit diagram I use for the control. Here the power wiring is not shown anywhere, so just focus on this drawing. Focus on it properly, then we shall discuss it. We shall discuss. You can screenshot it so that maybe you can follow it at your own time, slowly. Yeah. So we shall go one by one, step by step. We shall discuss this circuit, and we shall be marking as we go on. As we proceed with our discussion, we shall be marking in order so that we don't get lost. Yeah. So we have this one, first K1. K1 is here. K1 basically is for ensuring that we have supply for the controls. Either when we have, let's say we have dealer supply, or we have generator supply, so we shall have a common outgoing for the controls. Yeah, a common outgoing. So this K1 is more or less like an ATS by itself. Yeah, it's a small ATS, because the K1 here, you can see we have a fuse here. This control from, you see I've indicated DY here. This is the main, M1 mains, and this is the generator. So this is the incoming here, this fuse. Then we have an outgoing here. So from the generator, from the fuse of the generator, which is this one, you have R1. R1 will come here to the normally close contact of this auxiliary contact of the contactor. Then the outgoing side shall have a common one. On the other hand, from the generator fuse, which is down here, we have R2. R2 will come here. But at the same time, R2 is energizing the coil of the contactor. You can see R2 is coming here, the normally open part, and energizing the contactor. You can see even the neutral side is from the generator. So why do we do that? Because we don't want to keep this contactor energized. So it will only be energized, this contactor, just when we have an emergency, maybe there's power failure or something like that. That's the time we can energize this contactor. But there's no use of keeping it energized, maybe forever and ever. Yeah. So what we do, that's why we get our main supply through the normally closed contact. You can see through this. Then we have N1. So we have a common N here outside, and we have a common, which is I've indicated by one, a common live by one. So this is our one is a common supply, which now from here we can see a common supply from the main side, and from the generator side we have our one now. Yeah, and it is supplying everything. Yeah, it is the one which is, so we are done with that. And the coil here you can see N2 and R2. So as far as contactor 1 is concerned, then we have this KM1. KM1, yeah, this KM1 is the same contactor we are using also to give a signal to the generator for starting or stop. You can see through a normally close contact of KM1, that's where we can either start or run the generator when it is in auto side. Yeah, so the KM1 is only energized in case the power, this monitor relay one is okay, it has given a go ahead, then our contact there, which is normally open, it will close here. 1 and 2, it will close, then it will go and energize KM1. Yeah, through 2 is energized, and actually you can see when KM1 is energized, this yellow cable is not a phase, this is for the generator side. So you can see number 22 here and number 24. Down here is 24. You can see from this side is 24, so this one is 24. You can see 22, 24. Then we have 22 will come here for the signal, and also this 25 from outside, from the door, from the selector switch of the door. This is the selector switch here. You can see the 25 here. Yeah. So this is as far as the signal for starting and stopping the generator. Maybe I can clarify a little. You can see I've written here my switch is in auto position already. So this side that I will show you from the door. So my selector switch here, you can see there is red and there is green. The red one is normally closed, the green one is normally open. So already, that is when it is hand side, they will go out. Both of them are activated at the same time. So when you put in auto, basically what you are doing, this one you are making it to, when it is pushed from outside, this one it will close, and this one is already open. So this is our outer side. So from my paper here, we have 3. There will be 3. Now there are only 2. There will be 3. So the ones which look closed already is the green side. This one is the green side, and the green side. So when we put in auto, so this one is our signal for, this is the green side, normally closed. This is the red side. The red, and the red here. These ones, they are already open, the red. There will be 3. In this case, there are 2. There will be 3. So this is the red, and the red. Green, which is already now in closed position, because I have, as I have indicated here, switch is in auto position. So in this case, if you are selected, now we are discussing this signal for the generator. If this one is already in auto, so this is the outer side. So our signal will move here. It will move. This one is already closed. Yeah, it will come. If this one is a normally closed contactor of KM1, if KM1 there is main supply, this one will be open. So there is an open here. So our signal will not be complete for running the generator. It's only when KM1 is not receiving main supply, that is the time this one will go back to normally closed contact, and that's the time it will give the signal for the generator to run. So on the other hand, when you want to do things in manual or hand, when you do on manual on hand, This one, you will operate the switch from here. You operate that one. Now this one is not pushed. It will go to normally open position. This one will go to normally closed position. So this is the hand side. So this is the hand side. It will give the supply to this lower selector switch. This lower selector switch. You see our signal through 25. It will go through 23 to this selector switch. This selector switch is the one which can run. If you switch manually, it will become a normal close, and it will give the signal. It will give the signal to run the generator. So it is like this. It will come through here. Then from 23, this is the lower selector switch. Then we come here. Then it will give the signal on my plate there to run the generator. So I hope I have tried to explain. You can try to follow. So I'm done with this. We are done with this part. Another thing now, we shall start. We have discussed how we get to the one, which is our common supply, and how we get our common N. You see this N1, N2, then there is this common N, which I have looked to KM1, and this also, the N is going direct to the motorized of both. This is the DIWA or mains charging motor and generator charging motor. So this one, they will need, both of them, they will need a common N to energize. They will energize at the same time. So we have our common N here. So let's discuss something here first. See, you have B2, B4, A2, A4. We have L1 and A1. What do they stand for? So the A1 is the neutral, the A2 is the closing coil, the A4 is the opening coil, the B4 is for charging the motor, and so our neutral, the neutral we have just discussed here, this common neutral, come in here for the motorized one, motorized two. So it will come to A1. So where is our A1 here? Our A1 is down here. It's up here. You see the N. I see here. Same case applies to this one. N. Here, A1. So we have supplied there. At the same time, we want this one. We want it charged continuously. When it is on off position or off position, this one should have the supply for charging them, for charging this motors continuously. So we have our charging for charging the motor. We have B4 here, B4, and so we have one which should go to B4. And where is the B4? B4 is here, which is here. Our one is there, and actually then you loop B4 and B2, B4 and B2. You loop them. You loop them direct. I've looped using this small green cable. So I've looped here. I've looped here. Same case. I've supplied here, and I've also looped down. So B4, which is for charging, is also looped with B2. Otherwise it will not charge. Yeah, I will continue discussion on the other part. Okay. Shall discuss the other part. Then we go to the next step. We have done with this step. We go to the next one, which is number 3. So this one we have written generator MCCB. This is the contact or auxiliary relay here. So this is the generator side. The auxiliary relay is here. It will get a supply of 1, yeah, which is here, supply number 1. Then we have the normally open side of the generator MCB or the relay. This is the normally open side, which is number 3. That one we go and supply the lamp for indicating the generator MCCB is on. Then we have number 4, which in this case we are using for interlock. This is the electrical interlock I've already talked about. This one will interlock the main. So in case this one is on and this switch will flip to this other side, the lamp will indicate it is on, but generator side for closing it will not be on. Let me clarify, or let me explain further what we mean by closing coil. Closing coil is just an on coil for switching on. Opening coil is for switching off. It just means off. So for the closing is just switching on. Opening is just off, switching off. So here we shall interlock this other side. We are interlocking the switching on of the main side. The main side, yeah. And our main side, in this case, we have denoted by, we have written D1, Dubai Electricity and Water Authority, yeah. So when this one is off, it will flip this side, it will go to K2. Our K2 here is for the main side, for switching on the main side. So our K2 here, which is here, this side, our K2, when KM1 there, which is will be switched on through phase monitor and relay 1. When it is on, it will switch also here on. It will energize K2 along with KT2, the timer next to it. When it is switched on, then it has to switch on this part. When it has switched off this part, then there will be a little delay. There's a little delay for this timer. It will switch on and then going again to the generator interlock. There's another interlock here. So I have done two interlocks. There's also a generator interlock here, which is number 6. Then from number 7, you go and energize the closing of the main, which is here, down here, number 7. And number 7 here is A2. So the A2 here is the closing coil. So we go to another step. If you want to switch off, then also from the door there, if you are doing it manually, here it will be on. In this case our switch is in auto, like we discussed, but manually this one will be on. Then you can switch on from here, and there will be an interlock also. If you are doing manually outside, there will be an interlock. So this interlock is taking care of the manual side. This interlock is also taking care of the auto in both cases. So to the interlock here, and it will close. Opening is very simple. You can just push this push button and you can open or you can switch off. So there'll be a repetition of the same thing when you go to dealer side. Dealer side, I mean the generator side. The generator side, if there is a power failure, let's say there is a power failure. So what do we want? In that case, we want the generator to run. So in case there is a power failure, through this part, our generator will switch on. Once it is switched on, the first monitor in relay 2 will be on. Where is our first monitor in relay 2? Okay, I have not indicated the coil here. Let me see whether the coil for first monitor in relay 2 is here. Let me locate it. So this is our first monitor in relay 2. You see the E. So our E, through these fuses, our E will supply there, and 19 and 20 will switch on. So where is our 19 and 20 is here. This one will switch on, the first monitor in relay 2. Then through K2. This case K2 is for switching on the main side. This one, it has collapsed, so it has gone back to the normally close contact, and we are passing through the normally. You see number 20 there, through the NC of this contactor. Then we go out through number 21. Then we energize this coil for the K3 and the coil of the timer, this timer number KT3. Yeah, once they are on, then it will facilitate through this part to switch on or to closing the generator side of the MCCB. So we have this through main side. Through main side we have number 10, which is going to indicate the main is on, or DEWA. The main is on. Through number 10, through normally open contact here, we have our one as our common 3. Through this 10, it will go to energize the or go to the lamp for indicating that the main is on. Yeah. Then at the same time, it is used for the interlock. So how do you see it for the interlock? Through number 11, you go to K3.